Okay, so the last section we're going to talk about in Unit 7 is geometric mean. So we are going to use congruence and similarity for triangles within a triangle, okay? So there's two different ways to apply geometric mean depending on what you are given. It's also called the altitude theorem. If I would take one triangle and then we draw the altitude. So altitude is the straight height from the right angle to the other side of the base. And notice it's not equal parts. It's not supposed to be. It just has to make a right angle. And then if we think of this as three separate triangles, a triangle on the left, a triangle on the right, and then the overall triangle, okay? We kind of stack those up. What happens is there's some mathematical principles at play. So the first thing is we can find a relationship because we have similar triangles, okay? We can find the proportion of the altitude, which is that height, in the same ratio as the left side of the base of that left triangle is the same ratio as the right side, right part, divided by the altitude. That's because we would be turning those triangles around, and so that's why they're all in that relationship. So I showed you the top part to kind of understand it's not, even though they don't look like they're the same, we really have to turn those triangles to get the ratios. So because this proportion is true, we can cross multiply, and you get altitude times altitude is altitude squared. Is equal to left times right. And so this is what you're going to memorize. Sometimes I memorize that height squared equals left times right. So notice it's the left part that's being divided by the altitude. So you have to understand the parts and not just memorize the formula because you're like, I don't know what left is, I don't know what right is, but I memorize either one of these, okay? And so when you're going to use this formula is if you are given or no information about the hypotenuse and the altitude, okay? So this is called the hypotenuse because it's across from the right angle. These two sides are called legs, okay? And this would be probably back from 8th grade. So if we know or we're given any information and we don't care anything about the leg values, and this is going to be the formula that we use. Okay? So this application really can be used to calculate the height of the right triangle because it's eventually going to give us the information that we need to actually find the area of a right triangle. We're not doing area in this unit, but this is why we learn this theorem because sometimes you remember it's 1/2 base times the straight height length. So if we need to find the height length or the base length, we would need to use this theorem to get more information about it, the triangle, so we could find the area. Okay, so that's really why we learned this theorem. All right, so let's do two examples. So on the first one, notice this is my altitude. Altitude. This is my left, and this is my right. Okay, and so because of the formula, there might be some math that we need to simplify. So let's just see. So the formula is altitude squared equals left times right. And if you reverse that order because we're multiplying, it won't make any difference. So altitude squared is 10 squared. My left is x. My right is 25. Okay, so I would want to see this on your quiz. And then let's clean it up. 10 squared, I'm going to do it over here, is 100. And then 25x, I'm just going to put the 25 in front. Since those are being multiplied to solve, we will divide by 25. So x equals 4. Okay, and it looks smaller. If this is a decimal value, you go ahead and write the decimal. But we really do want the exact answer because when we go to find area, exact matters. Okay, so let's try example 2. This is going to be slightly different. So same formula. We know that altitude squared equals left times right. So altitude, here's my right angle. So this is my altitude. So x squared equals my left times my right. Okay, so x squared equals 12 times 8 is 96. Now, we've solved quadratic equations. Remember, we're going to take the square root of both sides. Square root and square cancel. Technically, when you take the square root, you do get plus and minus, except we're talking about a height length. So we are going to ignore the negative, okay? But the square root of 96, if you type that into a calculator, it's a decimal, okay? So no decimals. We need to break down the root and we look for doubles. So 96 we know is 12 times 8. We're going to break that down. 12 is 4 times 3. And 8 is 4 times 2. So remember, anytime you see a double, that gets to come out. The single 3 and the single 2 get multiplied back together. Okay? And this would be from first semester, so it's a good review. So x equals 4, and then 3 times 2 gets to root 6. All right? So no decimals. We want the exact answer. So you might have to break down square roots to get it. Okay? All right. Now, using the same idea of a right triangle with those similar triangles inside, this part of the geometric means is the leg geometric means. And so that's what the first formula, we called it the geometric mean theorem up there. So this one was about the altitude. This geometric mean formula is about the legs. So that's when we're going to use it. If we know information about one of the legs and part of the hypotenuse, okay? So it should be pretty obvious when you're going to use which theorem. So based on similar triangles, the ratio that's set up is the whole hypotenuse divided by one of the legs, okay? It won't matter which leg, so just one of the legs, which is one of the sides by the right angle, is equal to the same leg divided by the part. Now notice, the leg and the part are always on the same side of the big triangle, all right? Because there are two parts, you have to know which one you need to use. So keep that in mind. Now, when you cross multiply, I just memorized this because that's really how it works. Leg times leg is leg squared, and hypotenuse times part. So I say part of the hypotenuse by the leg. So that's what I remember. So leg squared equals part times the whole. All right? And it works on both sides. So first, you really have to identify first which geometric mean formula you need to use, and then which values you need to use. All right? So once again, we're going to use this when we are given or we want to know one of the legs and the hypotenuse values. So you might have to use both of them. All right, let's look at example 3 and 4. So I'm going to write down, I know it's leg squared equals part times whole, and it's hypotenuse. Okay? So I just memorized that part. So let's look. If I want to find x, so this is a leg, this is the hypotenuse because here's the right angle, and then this is a leg. So I'm just going to ignore this for a second, so I'll go ahead and erase it. So my leg is x. It's the part that's by the leg, so 4, times the whole hypotenuse, which is 4 plus 6. Okay? So make sure you're using the right values in your formula. So we get x squared equals 40, and then we'll want to take the square root. Now, if you type in the square root of 40 into a calculator, you do get a decimal. So that's how you know to break it down. So I'm going to do it up here. So root 40 breaks down into 4 times 10. 4 breaks down into 2 times 2. And 10 breaks down to 2 times 5. So remember, circle a double. the doubles go on the outside. 2 is single, 5 is single, and they don't break down more. So we're going to put those back together inside. So 2 times 5 becomes 10 inside. So x equals 2 root 10. Remember, we only want the positive root, and we want the exact answer. Now, to find y, we'll do green. We're going to do the same idea. So that's a leg. So I know 4 squared equals the part of the hypotenuse that it's by, so 6, times the whole is still 10. Oops, why did I write 4? I don't know why I wrote 4. I need this to be a y. Sorry, I'm not sure what I was doing. So y squared equals 60. And if we take the square root of 60, that's another decimal. So once again, we want to break that down. 6 times 10, 2 times 3, 2 times 5. The 2's are a double, so they come out. The 3 and the 5 are singles, so we multiply those back together inside the radical. Okay? Most of your answers will be radicals, but that's also why we've learned how to break that down. This is a review of it. We're going over it, so if you need more help, please email me. All right, let's look at the next. Example 4. This has 3 variables. So one is my altitude. So if we want the altitude, we have some choices. I can find that first, or I can find some of the legs, and we can't do the Pythagorean theorem. All right, so there's going to be some options. I'm going to use my leg theorem. So let's just find z. So z is a leg. So z squared equals the part of the hypotenuse, because remember, here's my right angle. So the part that it's by times the whole thing is 16, because 7 plus 9. Now, I think we've learned we're going to take the square root, so we really don't need to multiply these back together. The 7's going to stay 7, and 16 is 4 times 4, so here's the double. So z equals the 4 comes out, and the 7 is single. So I'm going to go ahead and label my picture. So 4 root 7. We can do the same thing for y. So y is a leg. So y squared, leg squared, equals the part times the whole is 16. So we're going to take a square root. So 9 is 3 times 3, 16 is 4 times 4. So 3 is a double and 4 is a double. That means they both come out and there's nothing left on the inside. So y equals, we'll multiply them back together, so y is 12. Okay? 9 times 16 is 144. So if you would take the square root of 16, you would get 12. Okay? So you can put them back together. You can break them down. It really just depends on what you see. The last thing that I'm going to find is x. Now, we have not reviewed the Pythagorean theorem, but you have 2 choices. We can do the Pythagorean theorem on this triangle because it's also a right triangle. So my leg would be 9. I'd have 9 squared plus x squared equals my hypotenuse is 12 squared. Now, we can solve that. Or, that's the Pythagorean theorem, we can do our altitude geometric mean theorem. So remember, my altitude squared equals my part times my part. I actually think this is faster than the Pythagorean theorem, okay? So I'm going to take the square root. The 7 doesn't break down. The 9 breaks down into 3 times 3, so there's a double. So x equals 3 root 7. Okay? And we would get the same answer if we followed through with that Pythagorean theorem. But the geometric mean will work. All right, so those are like 4, I would call them the basic problems. I wouldn't say they're easy, but now we can get into some more challenging problems. And you can kind of see what makes them more challenging is we have a lot more equations set up. So on example 5, we want to solve for x. So I'm given the altitude. I don't know anything about the legs, so we're going to have to use altitude squared equals left times right. Okay? So I know my altitude is 10. The left part is x, but I need to figure out my right part because I'm given the whole. Well, if I know that my whole thing is 2x plus 21, and I know part of it is x, that means I want to take that off to figure out what's left for the right. So if we take off 1x, I get x plus 21, and that's how much the right is. Okay, this is pretty challenging. So it's x times and then x plus 21. Anytime you have two terms together, I always put them in parentheses. So 10 squared is 100. And then we do need to distribute x times x times 21. And now this is going to be kind of a blast from second quarter. When you have x squared and x and a number, you need to get everything to one side so you can factor. So we're going to subtract 100. And I can't really subtract, but I can move it. So 0 equals x squared plus 21x minus 100. And now we need to factor. So we want to use the AC method. So first times the last. And I want the factors that give me that 21. So let's see. I know 25 times 4. If I multiply, that gives me 100. And if I want it to be positive 21, I need positive 25 minus 4. So remember, we rewrite this middle term. So x squared plus 25x minus 4 minus 100. And if you don't remember factoring, remember you can do the quadratic formula to solve. We're going to do grouping. So these have an x in common. These I can divide by negative 4. And so my parentheses match, so we put the outsides together and my parentheses that repeat together. And remember, we set each of these equal to 0. So if I have x minus 4 equals 0, x plus 25 equals 0, and we add 4 and subtract 25. Now, if we look, 4, I'd have 4 and 25. But if x is negative 25, we can't have a negative length, so this is called an extraneous solution. So x equals 4 is our only answer. Okay, definitely more challenging. All right, example 6, we are given a leg and we're given values on our hypotenuse and the altitude. So we're probably going to have to use both geometric mean formulas. So I'm going to start with my altitude one. So altitude squared equals left times right. So 12. My left is x plus 7. My right is x, or vice versa. It won't matter. So 12 squared is 144. And we're going to distribute that x. Once again, we have x squared, an x term, and a number. We need to get everything to one side to either factor or do the quadratic formula. So I will subtract 144. Okay. So then to factor, and I know this is review, but it's been a while, we need to do the AC method. So we have x squared times negative 144, and we need the factors that add to give us 7. So we know 12 times 12, but that'll give us 0 or 24. So we need to come up with other factors. So find some numbers that divide into 12. So what if we try 6? How about 6 times, and if we divide 144 by 6, I get 2, 4, 24. So if I have 24 and 6, I can add to get 30 or subtract to get 18. So that doesn't work. What if we try, what's another number? How about 4. So if we divide by 4, I would get 144 divided by 4. So we just got to find the factors. So 3, so that's 12, so 24, I get 36. Well, I could add to get 40 and subtract to get 32. So those factors don't work. So now I need, what's another number that goes into those? What about 9? So 144 divided by 9, I get 1. 54 is 6, so 9 times 16. I can add to get 25 or subtract to get 7, and that's what we're looking for. So I would want to do 16 minus 9. Okay, and so that's what we would write as the middle term. You don't always get the right factor on your first guess. Okay, so I'd like to show that. So we get 0 equals x squared, and then use these two terms. So minus 9x plus 16x minus 144. So then we group, factor out an x, factor out a 16, and so my outsides go together, and my repeats go together. And we set these both equal to 0. So subtract 16 and add 9. And then check, do they both work? Well, if x is negative 16, I do have a negative length. If x is 9, I get 9 and 16. Those are both positive. So x is 9. Okay. So we found x, but now we need to find y. So that's a leg. So we have leg squared equals part times whole. So y squared equals the part that it's by, which is 9, and then the whole thing. So if that's 9 and that's 16, we have to add them all together, and we get 25. So we'll take the square root. That's 3 times 3, that's 5 times 5. They're both doubles. So y equals 3 times a 5 that comes out, and there's nothing left for a root answer. So y equals 15. Okay, or I could have done the Pythagorean theorem. A squared plus b squared equals c squared. So the challenging problems typically include factoring. That's what makes them a lot harder. Okay. All right, so give those a try and good luck.